Welcome everyone to class 7 in the Cloud Solutions and API class. This is where we are going to review the class project. So it's entitled Data Engineering, Predicting Crypto's Future Market Cap, with crypto spelled crazy. I'm Jeremy Bergman, the Omaha Data Science Academy. And what this project is all about is really putting together all of the pieces that we've learned in the first 6 classes from start to finish. So everybody's set up resources, configured Azure, connected to a database, created pipelines, used APIs to do different operations and fetch data, and then even created a simple machine learning model and deploying it. This project aims to do is ensure that the students take all those skills that you've learned just in a bubble or individually, and now you're putting it all together to be able to engineer a full end-to-end data pipeline that includes REST API data. Yeah. So purpose, just mentioned it, to engineer an end product like what would be produced in a business environment by utilizing the knowledge in that course. Probably even more simply said, I feel like this is a project like you would see this if you went and worked somewhere, like from a data engineering this type of workflow, especially an analytical workflow to create a machine learning model or an AI model or something similar to that. And then creating an end product, like deploying it by API and then visualizing it in PowerBI. So I think it's a realistic of what you might encounter in the workforce using your skills. So I included this. I typically do this with projects. I have a process that I follow just as a consultant, and I'm doing data science or data engineering projects. So what this tries to encapsulate is this process also. So like understanding the business problem. So the business problem here, if you think about it as a problem, it's like trying to predict crypto market cap. This one's pretty simple. Sometimes business problems are pretty complicated, or they aren't as what they appear or anything. For this one, it's pretty straightforward. We're just trying to predict future market cap for all crypto combined. So understanding and preparing data. Understanding the data is a big part in preparing the data. So you're a little bit familiar with the crypto data that we have. Fairly straightforward, but if you don't have a great understanding, feel free to get a hold of it and explore it and look at some of the documentation there on the website that we're looking at. What's the name of that website? livecoinwatch.com, I believe. It'll tell you what some of the fields are there. So going in really understanding the data helps you prepare the data. Data prep is all the things from extracting, loading, and transforming the data the way you need. You can often do that. You can do that through Azure Data Factory pipelines, building the model, data flow, and pipelines. You can do that in Azure Machine Learning, a combination of Azure Machine Learning and your other tools like Synapse Analytics. Testing and evaluating the process, making sure it works end to end. That's probably the final step that you want to take, is just make sure in this process you can execute it all from start to finish. And then deploying it, monitoring it, and doing updates and maintenance to the process. So that's where we visualize it in Power BI. I think of a data science, it's a pretty common data science process. And when you think about it this way, it's when it makes sense for the data engineer on how you work with the data scientist or how you implement these type of things. All right. So project steps, you'll notice this graphic because we did this. We took a look at this in the last class 6. but it actually really pretty well highlights like all of the steps in this process. So you go from your unstructured files or your unstructured data or your structured data. You're pulling this from systems or spreadsheets or even APIs possibly. So this would be like our crypto data that we have, those CSV files, ingesting them and then storing them in data lake, analyzing them in Synapse Analytics, creating a machine learning model that you can update and retrain, deploying the model and visualizing it in Power BI. So I went through that really fast, but this will give you more or less like, this will give you pretty close to what we're trying to accomplish in this class, or trying to accomplish with this project. So I put my own comments. These coincide with 1, 2, 3, 5, 6, 7, and 8. I won't worry about 4 here. Kind of does the machine learning, does it itself. But if you follow these steps, 1, 2, 3, 4, 5, and I have another slide, 6, 7, 8, 9. Those will be the questions or the things that you'll need to do for the class project. So I'll go ahead and cover these. So most of us have already placed those crypto CSV files into the data lake. Then using a Azure Synapse pipeline to store that data in MySQL tables. So if you've completed homework 2, you already have this part of it done for the most part. So at least you'll have 2A done where you create the OLAP data model in Azure. And I provided some code in Slack to be able to build those tables. If you haven't already built those themselves, it'll save you some time. But I'll go ahead and show you this code. I'm pretty sure I've chopped a lot in here, so I'm pretty sure that everybody's probably thinking, oh, what is he doing with that code or dropping it in there? So if you take this code and you run it in Data Studio in your schema, it'll create these tables for you. And how that helps is that now all those tables are set up. You can create data sources out of them, and it makes it easy. These are already defined instead of having to define them yourself. They now follow the examples pretty well, so that you can take a look at like class 4 exercise that I just re-recorded today, and it would coincide with this data model. So it helps you, like, the point of this class isn't so much to like, yeah, data engineer will build data models, but I just want to make sure that you don't get stuck in this spot where you're just creating tables and messing around with data types or something. I've already created them for you. Right, so that code will help you out if you are, even if you're in homework 2 right now, even if you're still working on that, you could create those tables and create the pipelines that allow you to load those CSV files into the MySQL tables. All right. So in addition to this that we learned last week, we want to create a connection to livecoinwatch.com, REST API, and load newly refreshed data into MySQL. So what this will involve is creating a link service out to livecoinwatch.com so that you can use that data, that JSON data, response data that you're getting back from the endpoints, and then loading that into MySQL table. So it's really kind of like taking this data from the data lake, and now we're like live refreshing it from the API. You can get more on this. I just recorded a class 5 video that will walk you through setting up a link service for REST API, and then how you would feed that in. I'd recommend class 5 video for QB to help you out with that. So you can tell I want to walk everyone through this I want everybody to be successful with this project and be like, hooray, we graduated and we created this pipeline, and we have something to show for it. So really walking everyone step by step, and if you have questions, let me know. So once you've done that, once you have enough data in there, you can create a predictive time series model using Azure Machine Learning. You can use, I gave you a hint here to use the fact crypto overall view that I created after you load that table. You don't have to do that, but just a suggestion. I would, for it to create this predictive model, just use the AutoML. Let's use the AutoML functionality that automatically creates your machine learning models for you that we learned in class 6 last Friday. So that basically you go through the steps that we did in that exercise. Select the time series model this time. Create that model, and it'll choose the best model for you and make it easy to deploy it. Which is step 5 is deploying the predictive model via REST API. So we are right here. Don't worry about this part too much. Deploying the REST API here is good enough. Right here, we're good. So you can monitor and log it via Azure Monitor. Here, I'll go ahead to the next slide. It can help you in diagnosing any issues you have or making it successful. Or making sure like the deployment's successful. I didn't really put it as much as part of this project, but it is something that you can use. Actually, we'll really end up using Power BI for this a similar purpose. And once you deploy one of these models, you aren't necessarily done, right? So you can create a model, but as time goes on, you'll want to keep loading the most current data so you can have the most accurate current predictions. So retraining the model would involve getting more updated crypto data from the API in step 2, and then rerunning this model, redeploying it, retraining and redeploying it. So once you do that, you'll have a model that you redeploy. You can store the results of the predictive model in the Gen 2 data lake. So what I envision this as is that you get the predictions from the REST API in Azure Data Lake storage, and then you can visualize this in Power BI. So if you have a PC, a Windows-based machine, you can use Power BI Desktop to do this. And I'm loading it up myself. If you don't
Is it me, or does he sound like an old video game?
I think he's lagging.
I can hear
Very much.
Oh, we lost him.
We'll take a look at embedded Power BI here in a minute. That's if you aren't able to use Power BI desktop. I don't mind either way that you do it, because in the end, I'll just ask for screenshots for each one of these to make sure, like, to see that you retrained it, or that you stored these results. And then you could run a query on it while it's in the data lake. With these, just showing the different pipelines and that you deployed the predictive model and things like that. Screenshots are okay for me on all of these. Then, yeah, storing these results, model results, in Azure Blob Storage, so you can visualize it by Power BI, the predictive results. And then for a bonus, anybody who wants to ask themselves an interesting question, so asking yourself how the model changes each time you update and retrain the model with new data.
So you've used this model for a while for different things?
Use the same model for different things?
Have you used this model for a while for different things?
Have I created this crypto model myself?
Yeah.
No, I'm about to, though.
Okay.
It's
I
just
just was wondering.
It's
if,
just a project I thought of myself that I wanted to do. I'll end up doing it. I haven't made it. The goal is to make it through this by like Wednesday, so that Wednesday or this week, so I can show everyone the solution after they hand it in.
My question was more around the data. If you've been messing with this for a while or anything, if you've had data over the past, from past, type of thing. Because one of the things that'll happen, right, with us doing market cap, is if we have actual market caps at different points in time, then the situations change.
Yeah. No,
And that,
yeah. Yeah, the markets change, right? Even in crypto, I'd say right now they're in a different market now than probably even 2020, and definitely before that. So yeah, there's a lot of analysis that you can do behind it, not just creating the predictive model, but a lot of market analysis and stuff like that, trend analysis and technical analysis. Personally, honestly, John, I'm not that good at trading, but it's something I just want to dig into as a hobby, or see what I can find and create a predictive model out of it and see if it's any good. I don't know if it'll be any good or not.
so the other question I have is, where do we get a temporary version of something of Power BI that we can download that wants to charge a little bit of money for it?
It does. Power BI Desktop should be free. Well, Power BI Desktop itself should be free just to create your own dashboard.
Okay, I'll see if maybe I'm on the run link. Thanks.
Yeah, so there's Power BI Professional. It's like $10 a month, but you don't really need that because that allows you to publish to the cloud. They said the desktop features they should all be the same. That's where they get you, is like the $10 a month to use the cloud for each user, which is handy if you're working somewhere. But just to use Power BI Desktop, it should be free.
I found it. I just had to look a bit further.
Or
Sorry about that.
for whatever reason, if it's not, you can use Power BI. Yep. Oh yeah, no problem. It's actually a good question, because even Tableau, it only allows you to have it for like 14 days or whatever. That's the attractive part about Power BI for a lot of organizations, is the low cost compared to both the low cost and how well it integrates with current existing Microsoft platform, which like almost all businesses have like Microsoft products really. And like that whole stack, and Word and SharePoint and email and stuff like that. So the big corporations are actually leaning towards Power BI and like Azure platform over like just Tableau. Or you can use both in here, but I digress anyway. All right. So I provide a bunch of little project hints for each one of those tabs, for each one of the steps here. I just went through there to give you tips if like maybe to get you unstuck or what you need or things that I think might be helpful. So like for one, making sure you have all three of those files in there. The data lake, you have storage account that looks something like that, and you've created the folder. Then running that SQL code that I gave everybody inside of Slack, running that so it builds the tables for you so you don't have to mess around so much with trying to get that data to work. So I did that part. I created tables where the data types were good so that you can import the CSV files instead of having to monkey around a lot with the data types. And then I created the whole data model. I created the data model out of it. Second one is using a good way to explore the data or understand more about it is just using Postman, creating the post commands for all three of those endpoints that you have for the CSV files. I think it'll help you wrap your heads around help you wrap your head around the data, which also helps you create the process, help you with the process that you're creating. So the second part of that needs to go together using Synapse Analytics pipelines. I give some tips here to receive REST API JSON requests and place those in the MySQL OLAP model that I give you the code for. So I give you a couple of steps to look at this. This is also what I just recorded for class 5 today. So if you follow that, it should hopefully work for you. Same with steps 3 through 7. It should be class 6 video, actually. So the one that we did on Friday, last Wednesday, creating a predictive model using Azure Machine Learning Lab, using the crypto data that you've stored, and then deploying that model. And then this is one thing that we haven't done yet is exporting those model results via REST API to your Gen 2 data lake. But what you can do, I envisioned, is that once you deploy the model, it'll create a REST API endpoint. You get those predictions, and then you just save them as a CSV file in the Gen 2 data lake. So then you can just, out of Power BI, you can just connect to that file straight out of the data lake. It has the connectors for that. And then you could create your visualization of your trend and your prediction. And I gave a really nice, this one's a nice example of it today, like exactly what we'd be looking for. So a nice write-up on how to do it, connecting to the REST API and saving the files of CSV and data lake. So like our process that we've done for these pipelines, it's all about setting up the link services and then connecting the input and the output data sets, and then configuring the pipeline in the correct way to be able to get the data from the input source, which would be your REST API, and store it in your data lake, which would be like your output data set. And then do I have, let's have the last slide here. Oh, I did resources and recommendations. So I'll start with recommendations first. This, I have no problem with this being like a group project or a class project if everyone wants to work together on it. Even assigning different roles or different things that you want to do in the project. You could really do that is have different people work on different parts of the project if you want, like the data lake or creating the model and then working together to do it. That's not uncommon in enterprise for data engineers to work together. So if you wanted to do that, feel free to form a team, and you can hand in the homework as a team. Completing homeworks 1 and 2 was everybody to see. Most of the first 4 steps are directly related to what we did in homework 1 and 2. The rest of the project is really just an extension. Like I was telling Missy at the beginning of class, it's like what we learned last week, so class 5 and 6. And then it's just connecting all those pieces together from start to end, like you would see in an enterprise. You'll have 2 weeks to complete this project. I'll make it due, I wanted it to be Saturday. Is it Saturday, May 26th? Let me double check that. Yep, Sunday is May 26th. I intended this to be May 25th. So it could be May 26th. I guess it's not that big a deal. And then I'll grade them right away the following week. So that gives you almost 2 full weeks to complete the project. And I would say look at for all of your resources, your class notes, and these hour 3 exercises we've recorded. Hopefully those are helpful, where you can find something similar on the internet, or some of the class videos that we have inside of those slides, or inside of each one of the lectures. You could go back and refer to those, or there are just a ton of those resources out there. Like we saw utilizing YouTube, Microsoft Learn, especially if you get stuck. It's Stack Overflow to me. Like if you're just stuck and you're getting an error message, that's like I Google, and these are like the 2 things I click on first, either Stack Overflow or Reddit. And like I said, you can just, for all of these, you can take screenshots of the questions, just enough to have me see that you work through the process from start to finish, and that it works correctly, or it seems to work correctly. You could probably trick me on that, but I trust everyone, of course. I'm fine finding screenshots. And then if all else fails, if you're just really stuck, if you find yourself, I was just telling Brenda today, is I started my career as a data analyst, and sometimes I would get stuck looking at a SQL query for 2 hours, and I just need to call over a different set of eyes, or just asking somebody else to take a look at it after I've been looking at it for 2 hours and I swear the thing's right or that it should work. Or just reach out to me if you feel like something's taking a long time to figure out. I'll help get you through it, because the goal is really to let's put all these in place and have a final product that you can say that you engineered from start to finish and can be proud of, or even build on top of it if you want to after this class. So that is everything in the project. Are there any questions about the intent of the project, or any of these steps, or thoughts or concerns? Does it make sense how it's laid out? Trying to make it as practical as possible, like what you would actually see. And I think that does, in my experience, a pretty good job of it. I feel like this is something that you can, I've said build upon a lot of times, but you could show an employer, you can say, I took these steps and I did ETL, I did a pipeline, I loaded it into database tables, even I'll let you take credit for creating the lab model and everything. Then you created a model and deployed it by REST API, and then monitored the model. And then they could ask you questions about it, and you'd be able to answer them. So not quite all the way there for the certification class, but that's its own creature that I'm going to end up studying for too. Mostly around security and performance tuning and configuration and stuff like that. That can be kind of painful, and I feel like doesn't need to be as part of this class as much at this point. It gets in the way of learning the nuts and bolts of engineering these pipelines, creating these models and deploying them. Don't want to have everybody be spending like all their time just configuring something and never doing anything with it, or never doing anything else. And I know just from homework that a couple of people have run into that. So happy to get you to the other side of that. Anybody have any questions? Is it clear the purpose and these steps and what we're trying to do? Anybody thoughts or concerns? I really wanted to lay it out well for everybody. So usually that means awesome job of explaining, or Brenda, did I overwhelm you?
Yes, very much.
Did I overwhelm you? Just keep going, just take it step by step, go back through the lectures and watch the videos. And if you haven't completed the homeworks, just do these side by side. It'll help you complete homework 1 and homework 2, and then even the new homework, or even the work for the new lectures. I'm here for you. 2 weeks to work on it. So it gives you enough time. Work through it step by step, or if you get stuck, to reach out to me. If you get through this homework and you complete all these steps, feel pretty good about what you've learned in this class. Feel like I've done my job in 4 weeks. So that's my goal. That's personally my goal for students in this class. If there aren't any questions, I'm open to just working through anything outstanding. And if anybody's stuck on the homework, or you'd like to see something, or can be anything related so far in this class. That's a purpose of this class, is just to introduce the final project, and then be able to work on anything that we want. We will also do that on Wednesday. We'll take the exam. I hope that when I put them together, it usually takes students about an hour and a half to complete it. I'll give everybody some readings that you can read over and we can discuss, and then we can also work on things on Wednesday after you've had a chance to get started on this project. So I'm going to go ahead and end the stream. Now feel free to, of course, refer back to this, and I dropped the PowerPoint into it. James, hopefully that connection improved there for you a little bit. It may have been that video that I put on the screen, but if not, the recording should be loud and clear. So I'm going to end the stream, and I'll just go ahead and open everything up to questions. Ending the stream in 3, 2,